Welcome to AI Literacies on AI, large language models, and language processing. Today's provocation is AI is clever statistics and it has zero intelligence. What a disappointment. That is, we use the name AI as lens to a system, not as a denial of usefulness. But precisely how do these systems work? We need to understand something about the principles, how they work. Now, modern systems learn patterns by optimizing probabilities over vast datasets. They do not understand or intend or care about anything. Chatbots compute the next best token, class, or action given the training distribution that the developers and users are providing to those systems. That distinction matters a lot for policy decisions, design features, and everyday use by students and teachers. When data drift, they fail. When data encode bias, they will amplify it. When asked questions beyond their scope, they start hallucinate and output wrong things, falsities, even deceive their unsuspecting user. Our goal is to replace this mistake with method. We'll practice 5 literacies. Data literacy. That is, what is the model fed? Model literacy. How does it infer? Prompt literacy. How do inputs shape outputs? Evaluation literacy. What are the error bars and metrics? Ethics and governance literacy. What are the risks, rights, and responsibilities? Treat AI as a powerful statistical instrument. It is you who must calibrate it by yourself, verify the correctness of outputs by yourself, document the proper use of the apps by yourself, and never anthropomorphize it. AI lacks too many of the human type features that make us intelligent in our special and unique ways. Why is this point of view important? Because clear thinking beats hype and prevents avoidable harm that these technologies could cause. Recall what was called the Moravec paradox in the first week's introduction. Tasks adults find intellectually hard, like chess or calculus, they are relatively easy for computers, while sensimotor and perceptual skills that toddlers can quickly master, such as seeing, grasping, navigating, tasting, or conversational nuance, are extremely hard to automate. And this is because evolution invested vast computation in subconscious skills. Abstract reasoning, on the other hand, is much more recent, compact, and cheaper to simulate digitally. No doubt we want to be liberated from drudgery, not to outsource imagination. When AI cleans our rooms, we gain time for art, care, research, and life itself. We do not want degraded creative work and chores that still need doing. If progress means more space for meaning, then laundry and dishes, yes please. Creative voices, no thank you. We humans will stay at the center. Okay, now to understand the workings of the AI models, have a look at this diagram. It shows how a large language model LLM becomes a general purpose tool. On the left are the data types it can learn from. There can be structured data such as tables and matrices or text in any language, voice and videos, sensor signals, and images. During training, huge datasets with up to trillions of data points, really, from these sources are converted into tokens and fed to the model. In simple terms, a token is the basic unit of data an LLM reads and predicts, usually sub-word pieces plus punctuation and special markers. For example, unbelievable might tokenize as characters and morphemes un and believable plus an exclamation mark. Unbelievable. The system assigns these parts unique numerical IDs. Embedding layers turn token IDs into unique vector representations. And don't worry about the mathematics here, but it's not really much more than the high school mathematics used to be. Then the outputs that you see from the chatbots are actually productions of probability distributions defined over the vocabulary of language or language-like things. This is because during training, the model uh, learns to predict the most probable next token. The output from the incomplete sentence, such as the cat sat on the, is on the mat. What a surprise! And from the dog sat on the output is likely to be on the floor. The dog sat on the floor. In multimodal models, tokens can also represent image patches or audio segments. By predicting the next token over and over again, the model adjusts its parameters, and these are called weights, and acquires statistical representations of language, either written or spoken language, and vision, such as images and videos, and other signals encoded in those massive datasets that are used to pre-train these models. After this pre-training phase, the same model is adapted to tasks. Adaptation can mean fine-tuning on examples, aligning them with human feedback, connecting the system to external APIs and sensors, or adaptation can simply happen by giving clearer and better prompts by yourself, the user. In all these cases, it is the human user who is at the center of the whole process of training the large language models. The icons on the right list typical such applications and tasks. Information extraction from documents, instruction following, object recognition and image captioning, question answering, and sentiment analysis. The foundation model, as the whole model is called, can power many use cases because its learned representations transfer across such tasks and across different modalities. Now, remember though that your model does not understand like a person does. It finds patterns and it makes probabilistic predictions. The cat sat on the mat. The dog sat on the floor. Good results depend on you and everyone else. High quality data, careful evaluation, and precise instructions. For your undergraduate study, projects, for example, think of the large language model as a statistics-powered assistant or a tutor. You must describe the problem precisely, supply enough context and enough data. You must constrain the output format by your own critical thinking and reasoning, and carefully verify all facts and ethical implications of the output and of your own activities of AI use. As they say, gemstones in, gemstones out. Garbage in, garbage out. Now let us use here a tiny example to make a big point. If you ask an AI, how many R's are in the word strawberry? Now, you've heard this many, many times. Now, it might confidently say two. It might still do that. Well, that's wrong. It's three. So why does this happen? Large language models generate the most likely next words. They don't inherently count, verify, or fact check anything unless we guide them to do so. Okay. That tendency to produce fluent but incorrect statements is called confabulation, or more commonly perhaps hallucination. Now, the good news is that we can reduce hallucinations, confabulations with better prompts and a quick feedback loop that we provide to these systems. This slide offers 3 practical habits to do that. First, apply what is called here the Feynman technique. named after famous physicist Richard Feynman. Okay, explain the answer back in your own words and ask the model to check it. Okay, train the model, not let the model train you. Okay, then iterate. Ask the model, ask the app to verify using tools, search, code, or references, and to correct itself if evidence disagrees. Okay, tell them that they are wrong. You'll be surprised how often the second or third pass fixes the errors that you might not have noticed yourself to be there in the initial output in the first place. Second, be polite and clear. Models were trained on lots of data, good and bad. Lots of quarters, well-structured writing exists, but it's not so easy for these models to find it always. So polite, specific prompts tend to elicit fuller, more careful responses. Include the goal, the audience, the intended audience, the constraints that you want to have, and the format that you want to have, all of those in your prompts, in your instructions. Okay, third, treat prompt generators as helpers, not substitutes for your own work. Now, you could use, some apps that help you to design good prompts, but you still need to do the basic work by yourself. You still need to give some parameters, some advice, some structure to your initial inquiries, okay? Because these prompt generators, they produce very general level instructions. And so what is really essential here is your own knowledge, your own background, your own reasoning, your own critical thinking abilities. They are always essential when you want to have quality prompting. So a quick checklist here. First, state the task and the success criteria that you want to have for your own inquiries. Second, provide enough context and enough examples for the models to work better. Then ask for sources or a brief verification step. Tell the model that please check your own answer. Can you improve it? Ask the model to improve its own outputs. Okay? And when accuracy matters, when you really need to get the right answer, require these tools to use external checks. Okay? And then you can also ask the model to ask you if they need some clarification that you, as a human user, could provide and help them with. Okay. So it is you who are flying the plane. It is you who bear the responsibility for the quality of the answers. Better prompts won't eliminate confabulations and hallucinations altogether, but they will sharply reduce them and then make AI a far more reliable study and work partner for the future users. How many balls are there in this stack? Start counting. I believe you are getting at the right answer relatively fast and relatively well. But how is it with the large language models? Can they reason this puzzle out? I wanted to find this out myself and received the result that I'm going to show in the next slide first from using the latest ChatGPT model 5.0. And here's what I got just a few days ago. 20. And the system even provided a so-called explanation. Here's what it said. It is a 3D tetrahedral stack with 4 layers. The layers contain triangular numbers of balls, 1 top, 3, 6, and 10 on the base. 1 plus 3 plus 6 plus 10 equals 20. Many people count only the 16 visible from the front, but there are 4 hidden behind, unquote. So that's what ChatGPT 5.0 told me, and this, of course, is completely wrong. So you need to solve the puzzle first before you can ask the AI to try to solve it. Otherwise, you will be misled or fail your examination. Humans tend to see that way of solving the puzzles because they see the actual and partly hidden shape of the pyramid through experience. Because the human ability to observe, perhaps unconsciously, that there are gaps between the balls stacked here in this pyramid that is shown by the shading, and then infer correctly in this case from the shape, from the shading, that this is not a tetrahedral pyramid, but a quadrilateral one. LLMs do not arrive at their proposed and often wrong solution in this way of observing the geometric shapes from shades. Most often, in order to get reliable outputs, you need to handhold these systems and spoon feed the key information in precise prompts, perhaps pointing out the specifics of the images given, and then compare the answer that you get with the answer that you yourself has come up with earlier. And it is much more work. That's what one might initially think of as a shortcut to solutions and answers to actually get to correct answers, even for some relatively simple questions, puzzles, and problems. Okay, so does repeating the question help to get a correct answer from ChatGPT, for example? No, it doesn't. I asked the model the same puzzle a few days ago again, and the answer was 14. Reason? It's a three-layer square pyramid of spheres. Bottom layer 3 times 3 equals 9. Middle layer 2 times 2 equals 4. Top layer 1 equals 1. Total 9 plus 4 plus 1 equals 14. Not very helpful. Okay, so asking again and again doesn't necessarily improve, or usually doesn't improve, the quality of the answer, the correctness of the answer. These systems are what's called undeterministic. That's with the same questions they might provide different answers, and that it's not guaranteed that the answer gets any better. Okay, so you can try out yourself. Can some of the large language models from the HKBU generative AI palette solve this puzzle? You can try it out yourselves if you find DeepSeek or any other of those do better than the latest model that we had from OpenAI. So what we've noticed is that these systems do struggle to perform even simple tasks. And here is a quote. The slide quotes Ilya Sutskever, a key scientist behind current-day generative AI systems, explaining why predicting the next word can appear like understanding. When a model reads billions of sentences, those sentences encode traces of the world, how objects behave, what the social conventions may be, what the scientific facts are, and vast information about the everyday routines of human linguistic communication and behavior. By minimizing next token error, the network builds internal representations. These are the embeddings and attention patterns that compress these regularities. That compressed map is sometimes called a world model. Okay, that's what the LLMs build up. They build up the world model in this way. And it is not a conscious picture of the world, right? The systems models, they are not conscious of anything. It is a statistical summary that lets the system guess what the plausible, probable continuations for your prompts are to answer your questions or to plan for simple steps, to give advice, whatever the task may be. Okay, so think of it like learning a city from its bus routes and MTR schedules. You never see the city directly as it is. However, your repeated patterns reveal things like streets, sidewalks, traffic, neighborhoods, and people's routine movements across a city from point to another. So the model infers structure from text, and it does it in the same way. How do the words or tokens connect to each other? So it is about this massive connection between tokens, between words in language that creates the world model that AI has. Okay. Or to give another example, in the green box here, how do we know who the happy person is in this sentence? The man who wore the red hat that his sister bought from the store that closed last year is happy. It's not the store, or the sister, or the hat. Well, we know this, and the model knows it too, because these long-range dependencies between tokens or words can now be handled by what is called the attention mechanism, a mechanism that enables the transformer architecture, the architecture behind these language models to handle these long-range dependencies quite well. It sounds simple, and the sentence here, it's not difficult for humans, but it was actually rather hard to be able for the computers to be able to do the same. Okay. Now, I will not go into such details here about what's called the transformer architecture or the attention mechanism, but it has to do with how the context of the sentence is preserved in the memory of the computer system. Like humans, who might understand very well what it means to say, it was delicious. Okay, someone says, you hear someone saying, it was delicious. Now you or I do not actually know what it means in this sentence. What was delicious? I have no idea. I just made it up, the example. But those who could have been part of that conversation will understand the meaning of it. They might be talking about their dinner last night or something else. Okay, so in brief, the projections that these models make are imperfect. Imperfect. Training data is often incomplete. It may be biased. It might be outdated. It might be fabricated. It might be unreliable models. Then they can, have this what we call hallucinations or confabulations. These models might miss context outside of the text itself. It was delicious, and they will never find out what it means in that sentence. And they might mishandle some rare cases, edge cases, and novelties. The models generalize from known correlations, and they are not grounded in experience like humans who actually can be enjoying the delicious dinner. So use them as powerful pattern predictors, not as authorities of any kind. Okay, So for AI literacy, remember three practices. First, provide clear context so that the model can retrieve the right slice of its own internal map of the city or language, the text. Second, verify outputs with sources and other tools. And third, be mindful of ethics, privacy, and consent when working with datasets of any kind. With these limits, next word prediction of generative AI, which is what it is after all, can become broadly useful in practice, such as in generic tasks of summarizing texts and providing some, helpful explanations and advice, but perhaps still less so in solving problems of various kinds, like, how many, balls in the pyramid it cannot count. So here's an example of how this attention mechanism works. Here's an image, a famous image from a film. What does it tell us? How will it continue? It depends on your own training data. Some of us might hear that deep voice speaking to us in its exact words. No, I am your father. Some of us missed that particular part of life altogether. Either way, this one frame from a movie is about something. It has a meaning. In fact, it contains the whole plot twist of the film, doesn't it? Now, you can make your own next token prediction. What do you hear and see next? And you might need to click this uh, video yourself to see if that was right. Hello, Albert, our friend. His famous proverb is the perfect guiding principle to learning AI literacy too. I will close today's lesson with Albert's advice. You see, facts are cheap in the age of search and chatbots. Disciplined thinking is scarce. Your edge as skilled students is not recalling or reciting information, but knowing how to frame problems clearly, how to choose and justify data, how to recognize bias and privacy risks, how to test, verify, and cite model outputs, how to interpret metrics and uncertainty, and most importantly of all, how to decide when not to use AI in the first place. Those are all both ethical and intellectual decisions. Treat model responses as possibilities and hypotheses, not as truth of any kind. Try to ask better questions, decompose tasks for yourself, compare many tools, and keep a human audit trail of sources, processes, practices, and assumptions in your study portfolios. Also learn the limits of models, that is, the limits of the token-based LLMs, limitations of the pre and post-training data, as we discussed earlier, and the pitfalls of hallucinations and deceptions that these models are all too prone to. Keep in mind the ethics of deployment of these tools, such as fairness, accountability, and transparency. What Albert here means by education is cultivating judgment, embracing curiosity, and maintaining responsibility so that you can direct AI wisely in the right directions rather than be directed by it. And for these reasons, I will correct Albert a little bit and say education is not the learning of facts, but the training of LLMs to think. That is, in order not to make that step into the precipice, but to be saved from it. Thank you.